Okay, so in this video, I am going to work the entire review with explanations. Use this in a way to benefit you the most, which means you should not sit down with a blank review and just copy down what I do. That's really not going to help you. Your review should be completed. Then you can just kind of skim through the video to check your answers. You can watch the parts you need to watch. You can watch all of it if you want. But again, if you just watch it and copy everything down and you haven't tried it on your own, not the best way to handle it. But you are in charge of the video, so you can fast forward, rewind, pause, do whatever you need to do to make sure you are ready for the test on Monday. And not only should you look over this review, but you should also look over the quizzes that were returned to you and also go back over maybe some Delta Maths, whatever it is that you need to do. You don't have to do all of it. All right, so as I stated in class, on 1 through 6, the instructions I intended on adding and didn't was to sketch the parent function, give the parent function, and also plot the anchor points. We're not putting hash marks and counting exactly. We're just going to put them in the general spot, kind of like you would do when you are graphing. Okay, so I'll go through first and put all of the actual functions. This is a linear, so f of x equals x, absolute value f of x equals the absolute value of x, quadratic f of x equals x squared, cubic f of x equals x cubed, square root f of x equals the square root of x, and cube root f of x equals the cube root of x. Okay, then I will go and sketch my parent functions. So for the linear, it looks like this. Absolute value looks like this. Quadratic, cubic, square root, cube root. Okay. Anchor points for these. The linear has 3, but most of the time we don't really use them to graph them because we know how to graph lines other ways. Absolute value, there's only 3. You can do more if you want to, or sometimes you might need to get the pieces on the graph that you need, but there only has to be 3. Quadratic, there's 5. Cubic, there's 5. Square root, there's 3. Cube root, there's 5. And they're different for the different functions. So how do you figure them out? That's what some of you are struggling with. If you know basically where they go, like this on a picture, that's why I want you to have this written and this drawn, because it helps you figure it out. Okay, if you know this is clearly 0, 0, if x is 1, I substitute in 1 right here, I get 1. Then I substitute in 2, and 2 gives me 8. That's how I know this point is 2, 8. If I'm doing the square root, well, clearly 0, 0. Substitute in 1 in here, I get 1. If I substitute in 2, I'm going to get the square root of 2. That's yucky, don't want to count that. So I have to think, what's the next number I can substitute in to get a pretty number out? So that's what makes this 4, 2. It's the only time you think about substituting in numbers, okay? We're not making t-charts for you to be able to go and plot points. These are transformations, not substituting in numbers and plotting them on the graph. All right, so then let's look at this piecewise. So the first thing we want to do is evaluate. So if I have f of negative 7, so I have to look over here in my domains and figure out where negative 7 fits. Well, negative 7 is not greater than 2. It's not between 2 and negative 3. It is less than negative 3, so I'm substituting it into this one. So this is going to equal negative, then negative 7 plus 5 cubed plus 4. So negative 7 plus 5 is negative 2, cubed is negative 8. Then a negative negative 8 is 8 plus 4, so I get 12. Then I have to look for negative 4. Well, negative 4 is less than negative 3 also, so I'm substituting it into the same one. So that is equal to negative 4 plus 5 cubed plus 4. So negative 4 plus 5 is 1. 1 cubed is 1. 1 plus 4, I get 5. Okay. All right, so then I'm supposed to graph this function and give the domain, range, and discontinuities. So I have 3 parts I'm going to graph. Okay, 3 parts, which means I sketch 3 little parent functions. I have a cubic, I have a quadratic, and I have a linear. I'm going to put my anchor points on here, just like we did on the one above there, so I can make sure I use them all, because there are specific points I am looking for. They are not plotted. You are not getting credit. Don't care about the line so much. All right, so let's look at what we have here. The first thing I'm going to do, or the second thing, because the first thing was that. The second thing is I need to find my boundaries. This graphing is the same graphing we've been doing. The difference between this and between piecewise functions and that is that I have boundaries. So I have to actually substitute this in. So I substitute in a negative 3. Negative 3 plus 5 is 2. 2 cubed is 8, and that make that negative. So negative 8 plus 4, that's negative 4. So at the point negative 3, negative 4, that's my x value. Just figured out my y value. This is less than, not less than or equal to, so it is an open circle. So I'm going to go 1, 2, 3, 1, 2, 3, 4. That is my boundary. That is the only number that I substitute in to plot on the graph. The rest of it is transformations. I use my anchor points. Okay, so I'm going to start off with, for the cubic, this would be negative 2, negative 8. So I'm going to go to negative 2, negative 8. I'm right here. Then I'm supposed to reflect it in the x-axis, so I end up here. Then I'm supposed to go to the left 5, 1, 2, 3, 4, 5, and I go up 4. And I'm way off the graph. Not going to actually plot that one. So that was this one. So then I'm going to move on to this one. Negative 1, negative 1. I reflect in the x-axis. I move to the left 5, and I go up 4. That point I get to plot, because all of this stuff has to be to the left of this open circle, because all of my x values have to be less than negative 3. All right, so then I did that one and that one, so now I have 0, 0. I'm here. I reflect, nothing happens. I go to the left 5, and I go up 4. That's another point. Then I do 1, 1. Okay, so I'm at 1, 1. I reflect in the x-axis, go to the left 5, and up 4. Then I have this point, which is at 2, 8. I reflect in the x-axis, go to the left 5, and up 4. That puts me here. I don't fill it in. That just happens to be the anchor point. I know what the shape looks like. So I know, remember I had this point like way up here somewhere. It's going to come down like this to right there. And this has an arrow because it keeps going. That is where it gets chopped off with that boundary. So then I move on to the next one. I have 2 boundaries on this one, a left and a right. So I substitute in the negative 3 here, which means I'm going to have a point that's negative 3 something. So negative 3 squared is 9, but then this is a negative 9 plus 2 will be a negative 7. The other boundary, I substitute in 2. 2 squared is 4, make it negative. Overall, that'll give me a negative 2. Okay. So I go to negative 3, negative 7. That is a closed circle. Then I go to 2, negative 2. That's also a closed circle. Now, again, those are the only points that I substitute in x to find y. The rest is transformations. Okay? So I start here with negative 2, 4. So I'm at negative 2, 4. I'm supposed to reflect in the x-axis and go up 2. So I reflect in the x-axis and go up 2. And I can plot that point because it's between the 2 endpoints. That's why I plotted those. I have to stay in between those. Then I move on to this one, which is negative 1, 1. I reflect in the x-axis, go up 2. Then I'm at 0, 0. I reflect in the x-axis, nothing happens, I go up 2. 1, 1. I reflect, here's 1, 1. I reflect in the x-axis, go up 2. 2, 4. 2, 4. I reflect in the x-axis, go up 2. Well, that's my other endpoint. So my curve looks like this. And I stop because, remember, I have boundaries. That's the whole point of a piecewise. Now my third section here. I only have a left boundary here, so I substitute that 2 in. You give me 2, and then -1 minus 2 is -3. So I'm going to go to 2, -3. Oh, guess what I just realized I messed up on. So that's supposed to be closed. And then I'm looking, I'm like, oh, that's bad. That makes it not a function. This was supposed to be open. I don't know why I said they were both closed. So let me fix that. Open to there. Oh, now that looks a little wonky. Goodness gracious. All right, well, that wasn't any better. Okay, so I have this point, and then this is a line. You should be able to look at that and know what that slope is. That slope is -1, which means negative slope goes like that. So from here, I'm going to go the right 1 and down 1. That's my second point. That's all I need. And I can draw this in. And that's that third piece there. Okay. So my domain. I start out here clearly at -infinity. As I go, okay, there's no x value here, but it gets taken care of there. So all those x values are taken care of. Same thing here. I'm going all the way to infinity. My range is going to start down here at -infinity. I check my holes and stuff and make sure all the y values are accounted for. They are all the way from -infinity to infinity. I have 2 discontinuities. They are both jump. So I have the jump discontinuities at x equals -3 and a +2. All right. Okay, now let's talk transformations here. It says if the quadratic parent function, so quadratic parent function looks like this, is reflected in the y-axis, which means it affects x, and vertically compressed by a factor of 1/2, write an equation to represent the new function. All right, so if I reflect in the y-axis, it has to affect x before whatever the operation is. In this case, it's squared. So I'd have to have a negative x. And then the only other thing that's happening is a vertical compression. So this is inside before we square. The vertical compression is on the outside, and that's your new function. 16, cube root function. So f of x is equal to the cube root of x. It's horizontally, it says horizontally stretched by a factor of 1/4. That should say compressed, sorry. It's horizontally compressed because you don't stretch it with a factor of 1/4. It's horizontally compressed by a factor of 1/4. So that means it affects x. It's on the inside. Remember, x lies. So if I'm horizontally compressed by a factor of 1/4, I'm actually multiplying by 4, okay? And then I'm translating 5 units right. That also affects x. This has to be in parentheses, x, and since x lies, it's subtraction to go to the right. And then it says 3 units up. Well, that's going to be outside. All of that stuff has to be inside the cube root, and then outside the cube root, I have a +3. That is my new function. Okay. So here it's asking us to do the opposite and to describe the transformation. So I have 1, 2, 3, 4. I have 4 that I'm going to talk about. This negative is a reflection. You can't just put reflection. You have to put it in which axis. It affects y, so it's a reflection in the x-axis. Oh, let me move my little dots here. write too big. Then this 3, it's outside of the operation, so it happens after we cube it. So that means this is a vertical stretch. You can't just say vertical stretch, it's a vertical stretch by 3. This 1/2 is being multiplied inside before the operation, so it affects x. X lies, so even though that's smaller, it's actually a horizontal stretch, and you have to use the reciprocal by 2. Then the 7 means we go up 7. All right, so if we want to describe them all here, I have 1, 2, 3, 4. I have 4 again. So make my little dots so I don't leave anything off. So this 2/3 is being multiplied after you take the square root, so it's on the outside. So that is vertical, and this is less than 1, so it's a vertical compression by 2/3. This negative is on the inside, so it affects x, which means it's a reflection in the y-axis. The 5 means we go to the right 5. 2 means we go up 2. And there's your transformations. Okay, so now we're going to graph. So guess what a lot of you got points off on your quiz for? And someone was like, you said to do that? Yes, I said to do this. Every single graph I graphed with you, I said, before you even start graphing, you identify the parent function. This is a quadratic, so f of x equals x squared. Then the next thing you do is draw a sketch of your parent function. It doesn't have to be huge, it doesn't have to be perfect, but make it big enough where you can actually place these on there. It will help you make sure you're using the right points to translate or transform, and it'll also help you, make sure you use them all. Because I'm looking for 5 points, 5 specific points, not x's that you decide to pull out of the sky and substitute in. These 5. It's not about making a t-table, it is about you knowing where the parent function is and transforming it on the graph. Okay, so, and then it would also be helpful to list out my transformations here. So I have 1, 2, 3. So I'm going to have a vertical stretch by 2. I'm going to go to the right 3 and down 4. Okay, because if I don't write them all down, I might miss one somewhere. So here we go. I'm going to start with this one, which is at -2, 4. I'm going to have a vertical stretch by 2. So my y value is 4. I double it, it becomes 8. Then I go to the right 3 and down 4. That's my first point, this one. Then I do this one, -1, 1. Vertical stretch by 2. I multiply my y value by 2. My y value becomes 2. Then I go to the right 3 and I go down 4. There's my next point. Then I have 0, 0. Vertical stretch doesn't do anything, but I go to the right 3 and down 4. Now, you can do the other 2 points by symmetry. That's fine, but if you do that, you better make sure you know what it's supposed to look like, because I've seen a couple people say, oh, I did that with symmetry, but your graph is so wonky and wrong. The parabola, it didn't reflect down, so it still opens up. So if I'm going like this, it's going to have to come up this way. So I can put this point here and this point here. So then when I sketch it in, it should look something like this, but oh my gosh, goodness gracious. Okay. There we go. That's not too terribly bad. All right, so then my domain, -infinity to infinity. My range, I start here, bottom to top. My smallest y value is -4. My biggest y value is infinity. Never actually make it there. X-intercepts, I can see that I have 2. I don't get to guess off the graph. I got to go find it. I didn't give you a whole lot of room to do that, I know, but I'm going to try and cram it up here, I think. So my x-intercepts are when y is 0. So 0 equals 2 times x minus 3 squared minus 4. So I'm going to add 4 to both sides. So 4 equals 2 times x minus 3 squared. Divide by 2, I get 2 equals x minus 3 squared. Then I need to take the square root of both sides to get x by itself. So the left hand becomes plus or minus the square root of 2 equals x plus 3. I'm sorry, no, it doesn't. It's x minus 3. X minus 3. Then I add 3 to both sides. So x is equal to 3 plus or minus the square root of 2. So my x-intercept is 3 plus or minus the square root of 2, comma, 0. And remember, x-intercept means ordered pair. Zeros means it's a set of numbers. All right, so then I also need my y-intercept. Y-intercept is when x is 0, so I need f of 0. So that's going to give me 2 times x, I'm sorry, no, not x, 0. 0 minus 3 squared minus 4. Well, 0 minus 3 is a negative 3 squared is 9. 2 times 9 is 18, so I have 18 minus 4, which means my y-intercept is 0, 14. Okay. All right, my critical points. I have one. It's right here. I have an absolute minimum at 3, negative 4. It is increasing, starting here at 1, 2, 3, from 3 to infinity, and decreasing from negative infinity to 3. In behavior, as x approaches infinity, f of x approaches, so x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. All right, so there's that one. Now let's look at the next one. Okay, so this is a cube root. I draw my little parent function here. Put in my anchor points. Write down my transformations. So I have 1, 2, 3. So I have a vertical stretch by 2. I'm going to go to the left 4, and I'm going to go up 3. Okay. So I start here. This is negative 8, negative 2. So I'm right here. I have a vertical stretch by 2. So that becomes negative 4. Move to the left 4 and up 3. So this point's a little far out there, doesn't really help me. So I try negative 1, negative 1. Vertical stretch by 2, left 4, up 3. I can put that point there. 0, 0, stretch doesn't do anything. I just go to the left 4 and up 3. 1, 1. I have a vertical stretch by 2, so my new y value is 2. Go to the left 4, up 3. Last one, I'm at 8, 2. A vertical stretch by 2, so my y value gets doubled. It becomes 4. I go to the left 4 and up 3. Okay, so that's what I have, and I have to keep in mind what this looks like when I try and go and sketch this in so I don't do anything weird, which I've seen some weird stuff. My arrow would not be pointing up here. That does not make any sense. This one is laying down, so it has to come from out here. I have a point of inflection there, and then it keeps going that way. So you have to show that you have an understanding of what's going on with the graphs. Okay, so let's look at the domain and range. They are both negative infinity to infinity. Then my x-intercept, so clearly I'm going to have one. I need to go figure out what it is. So my x-intercept is when y is 0. So 0 equals 2 cube root of x plus 4 plus 3. So I'll subtract 3 from both sides. 2 cube root of x plus 4. Then I'm going to divide by 2, so I get negative 3 halves equals cube root of x plus 4. So to undo the cube root, I'm going to have to cube both sides, so that'll give me negative 27 over 8 equals x plus 4. Subtract 4 from both sides, so negative 27 over 8 minus 4 equals x. Get my common denominator, so negative 27 over 8 minus 32 eighths equals x, so x equals negative 59 over 8. So my x-intercept is negative 59 over 8, comma 0. My y-intercept is going to be when x is 0, so f of 0, I guess I'll kind of do it up here, f of 0 equals 2 cube root of 0 plus 4 plus 3. So 0 plus 4 is 4, cube root of 4 is cube root of 4. So my y-intercept is 0, and then 2 cube root of 4 plus 3. My critical points, I have a point of inflection right here. So point of inflection at, that would be at negative 4, 3. Increasing, it's increasing over the entire domain, so it's not decreasing at all. In behavior, as x approaches infinity, f of x approaches infinity as well. Then as x approaches negative infinity, f of x approaches negative infinity. Okay, so now we are going to look at these piecewise functions and come up with the domains and ranges and discontinuities. So my domain, now, and as I told you in class, that I know it doesn't show arrows on here, but there are arrows on here. I don't know why they're not actually there right now. Okay, so my domain. My x value is going to start out here at negative infinity. I have a continuous domain until I get to here. There's not an x value there or there, so there is no x value at negative 3. So it goes from negative infinity to negative 3. Then I will union that, start back over at negative 3. Then I go along the way, well, this one, that x value of 2 is taken care of, so I'm good. So I keep going. Well, here, there's an asymptote, so there's no x value there. That's at 5. So it goes from negative 3 to 5. Then I have to start over again, and I go from 5 to infinity. My range, I start down here at negative infinity. Then all of these y values are all taken care of all the way up until infinity. Discontinuities, I got a few different things. So here at negative 3, kind of looks like a jump, but there's a hole there actually for the whole thing. So this is actually point or removable. And remember, these, when you tell where they are, they're just at x values. That's at x equals negative 3. Then here, this one is a jump because I'm jumping from one point to another at x equals 2. And then my asymptote gives me infinite at 2, 4, 5, x equals 5. Okay. All right, so let's look at this one. My domain, I start way out here at negative infinity. So all of these x values are taken care of, including that one. Then kind of snap together, keep going. That's good. Keep going all the way to infinity. My range, I start down here at negative infinity. As I look up, all of these y values are all good till I get to here. So that's it, 2, 4, 6. So I'm going to go from negative infinity to 6. That is open, so I do not include it. Discontinuities. I have 2 jump discontinuities. X equals, I got a -2 and a 1. Okay. All right, then lastly, we are going to graph another piecewise function. Okay, so I have 3 sub-functions, so I have 3 parent functions I need to think about. I have a linear, I have an absolute value, and I have a square root. So I'm going to put my anchor points here. All right, so then I'm going to substitute in so I can find my boundaries. That's the only reason I'm doing that. I substitute in -4 here. -4 times a -3/2 is a +6 minus 6 is 0. So I have -4, 0. All right, so I'm going to go plot that point. -4, 0, and that is an open circle because of this. Then my line that I have, because it's linear, has to be to the left of that because all of the x values have to be less than 4. This has a negative slope, so although it's linear, I know it's going that direction of -3/2. So from here, I can go up 3 and over this way 2. And then I can draw in that piece of that line, just like that. All right, so then I have 2 boundaries on this one. I'm going to substitute in my -4. The absolute value of -4 is 4, but then I make it negative, so I have -4, -4. And then my other point, when I substitute that one in, the absolute value of 1 is 1, so then I'd have 1, -1. So I'm going to go plot these. These are both closed, so -4, -4, and then 1, -1. Okay. So I have my 2 boundaries here. This is an absolute value function. I'm going to go use my anchor points. I'm at 1, 1. I start there. The only thing I'm doing is reflecting in the x-axis, so I reflect down here and get this point. Then I do 0, 0. I reflect in the x-axis, which means nothing happens, and there's my point. Then I have 1, 1. I reflect in the x-axis, I end up right there. So I can't go any farther. These are my boundaries, and this is what that piece looks like. So then my third piece, I'm going to substitute that in. X is 1. 1 minus 1 is 0, so that'll be 1, 3, and that is an open circle. My transformations, I'm going to go to the right 1 and up 3. Okay, so here are my anchor points. I start here at 0, 0. I'm going to go to the right 1 and up 3. Well, that is where that point is, but I don't get to fill it in. It still has to be open. So then I use 1, 1. So then I go to the right 1 and up 3. Then I have this anchor point. How am I supposed to know what that is? Well, either you just know them or you think about this is f of x equals the square root of x. Square root of 0 is 0. Substitute in 1. Square root of 1 is 1. Okay, so what's the next number I can put in to get a pretty one out? That'd be 4. So I'm going to start at 4, 2. Then I go to the right 1 and I go up 3. It looks like that. Okay, so then my domain. I start out here at -infinity. My domain is continuous for all the way to infinity. My range, I don't start at -infinity. I start here, which is at -4. I include it because that's a closed circle. Then my range is continuous all the way up to infinity. I have 2 discontinuities. They are both jump. It's at x equals -4 and 1. Okay. And that's it. So remember, not only should you look over this review, but also look over the Delta Maths that you have done and all of the returned quizzes and make sure that you are prepared to do well on this test.